sense to that. All right. So I'll let Jayesh introduce himself better than me, I guess, but he is a CNCF Community Bridge mentee and a Microsoft Learn student ambassador. Loves cloud and works with Flutter as well as part of the development, coding, you can say. Quickly a bit about me, and then I'll hand over, the mic to Jayesh. My name is Sangram. I come with a little over 15 years of technology experience. Most of my experience has been in the virtualization and then obviously over to the cloud computing, which obviously is a trend post the virtualization era, right? I spent more than half of my work experience on various cloud platforms. Most of this has been a tremendous learning experience, more than just putting it as a number out there. So had experience moving payloads like payment solutions and web servers and telecommunication stacks to cloud, which are slightly challenging compared to running a web server or maybe a mobile application, right? I advocate cloud native solutions mostly to startups. I work with them a lot. And whenever I get time, I do speak at various conferences as well. I've spoken at the Open Source Summit twice last year, making use of the Corona time, gives an opportunity to kind of do it online, right, rather than traveling. So with that, here's a quick, again, snapshot of the agenda that we have. We'll go through what is cloud native, mostly focusing on what is cloud native computing and application development. What is Cloud Native Computing Foundation, various popular projects around it, a bit about the mentorship program. So all of these three is something that will be covered by Jayesh. He being a Community Bridge mentee knows a lot more about this. So no one better than him to kind of put it across to all of you, right? I'll then end this with some cloud native stats that I have collected, over from 2019 to 2020. I use them a lot in a lot of my presentations. And we'll talk about some of the skills and tools that you should have if you want to be in the cloud native domain, if you want to be a cloud native engineer or pick out one of those cloud native roles. You might be an experienced professional, or you might be someone who's just getting started. You might be someone from college. There's always something for all of you, right? So with that, it's over to you, Jayesh. Thank you. Stop sharing here.
Yeah, thank you, Sangram. I've started sharing my screen. Can you see it?
Yeah, visible.
Yeah, sure. So as Sangram already mentioned, we're going to talk about cloud native and what it is. And then we talked about the CNCF, which is the Cloud Native Computing Foundation, and understand why it is important, what it promotes, the projects which are under it, and how you can use those components for your own solutions, or maybe you can contribute to the product itself. So we'll begin. Now, some things about me. I'm a third year undergrad, and I'm from IT Bhubaneswar, pursuing electronics and communication engineering there. I'm also a student ambassador with Microsoft for the around 2 years now. It'll be 2 years in August. I've also been a Community Bridge mentee for CodeDNS. CodeDNS is again a part of CNCF. It's one of the organizations there. And I've worked on a health check built for Kubernetes. And we'll talk more about that later, maybe. And apart from that, I love to make videos on different concepts, maybe mostly cloud computing as well. And I write blogs on Medium about different things which I build, maybe Flutter development or Azure and other things as well. And I love to speak at conferences like this one and meetups as well. And the next thing is I love open source. I've made contributions to Azure, Dapper, and other organizations which I like. And I'm on Twitter at WJS. You can find me. So let's jump right into it. So we'll be covering the cloud native approach to development. I'll show you what the approach looks like and how is it different from the monolith development that we are used to. Then we'll talk about microservice architecture. Like this is the, you may have heard of microservices, and I will show through a few diagrams how things are organized using microservices and what containers what role the containers play in such architecture. Apart from that, I'll talk about CNCF, what it is, and we'll see a few prominent projects in the CNCF. You may have heard of a lot of these projects, but we'll go over them one by one. And lastly, we'll see how we can start contributing to all of these projects. Later on, Sangram will also talk about the skills that you require and other statistics. So yeah, what are cloud-native applications? So just put it simply, cloud-native applications are those which are built using a specific set of technologies which make your application scalable. By scalable, I mean you can try to increase the number of replicas, the number of instances of your application as the demand grows or dies. So this is one of the parts. And the other part is making your application portable. Like that, using these technologies, they have an aim to make your application be able to be deployed anywhere on public cloud, private cloud, on premises. So these are the set of technologies which we refer to as cloud-native technologies, which if you build your applications using these technologies, you are sure to have scalable and portable applications. So we'll look at what these technologies are. So put it very simply, cloud-native approach is taking your application, distributing it into different microservices which can talk to each other. And if you look at on your screen, you'll see some terms like Docker, Kubernetes, DevOps, GitOps. So it's okay if you don't understand what these things mean. So you'll be looking at all of those again. But the entire theme is take your application, package into different containers. Like, say, for example, your application might have different purposes, like setting up orders or retrieving a list of restaurants for a food service app. So in this case, all of these different functions can be grouped into individual containers, like self-isolated independent containers who can talk to each other. So you take your application, separate into individual containers, and then you can orchestrate those containers on some platform. Orchestration, what I mean by orchestration is you can deploy these on different computers across different regions, and you have softwares for how you can manage which computer should run what applications and such and such. So this is the entire premise behind cloud native, and we have a lot of other things. And mostly when you're using cloud native applications, you depend on a set of principles called GitOps. Like you may have heard of DevOps before, like development and operations together. And you also know about GitOps. I'll be introducing those in the next slide. So GitOps is used for managing your applications when you're deploying it on Kubernetes or other cloud orchestration platforms. So what it does is it takes Git as the source of truth. So when you have a repository somewhere, maybe on GitHub, so you have all your code there, all your code for application as well as your infrastructure. For example, if you are planning to have so and so number of computers in such and such region, or you plan to have the specifications of those things, so this forms part of the infrastructure. So you store that as code as well. And apart from that, you also store all of your application code in GitHub too. So when you're making any changes to your code in GitHub, you should be able to automatically deploy it across all your cluster, right? This should be the ideal way. So Git is treated as a source of truth for all applications and infrastructure. And then if there's any edits that are being made, if you look at the small diagram that I have at the bottom here, so any code changes that you make to your Git code, that should trigger a new container to be formed. Like if you make any changes to one of the logic in some of the code, then this should make the older containers redundant, and you should have a new container built and pushed to some registry, right? So this is the idea, and then you can update on a rolling basis your entire cluster so that your new changes reflected across all your regions, right? This is the idea behind GitOps. Like there's a lot more to it. You can maybe go ahead and search on your free time how it works, and you have really good articles on it. So this is the basic idea of GitOps. Yeah, so now we'll look at a few examples and through diagrams and try to understand how this cloud native approach looks like. So on the left, you can see you have the clients, the client mobile app, the web app, the browser, and stuff like that. And on the right inside dotted area, you have your backend system. Now, you might imagine that in case of, if you're not using cloud native approach, you'll have, say, a single application run on a virtual machine somewhere. And this particular application will try to handle all of the different queries. For example, we take the example of the food ordering app again. So you might imagine there are cases like ordering or checking the status of your order. That is one of the things. And the second task can be retrieving a list of restaurants. So these are two separate tasks, and this require two separate databases. So the first will require a database of all the orders that you have, you and the other customers have. And the second database will be a list of all the restaurants, their timings, and all the other metadata about it, right? So having all of these things in a single application would mean that if you have to scale, say, just the orders part, you won't be able to do that, because if you scale a single, if you can't scale each of the parts individually in that case, right? So what Cloud Native does is it takes your application, splits into microservices. Like you can see the red microservice box here and the green microservice box here. They each are served by different databases, and databases choice can also be dependent on what kind of application you're using. If you want fast access, you might want a different database than you want for large amounts of data, right? So you can have different databases for different microservices, and you can make them talk to each other. So this is the first microservice. This is the second microservice. The message broker is usually used for sending messages to and from different microservices. For example, if my restaurant microservice would want some information about the order from the order microservice, so it can talk to the different microservices using gRPC or other protocols. We'll be looking at gRPC is also one of the project center Kubernetes we'll be talking about later on. So this is how you communicate between different microservices. And then there's something called a monitoring service, for example, which allows you to debug your applications to find out if all of your microservices are working as they should be. It gives you metrics on each request made to microservices and stuff like that. Right. So this is one of the ways in which you can build cloud native application. Yeah, so this is to give you a more idea about what Kubernetes and Docker and what role they play inside of this cloud native approach. So you can look at the left where you might have an idea of the traditional way of deploying applications. So you have a hardware, say for an example, any computer, then you have an operating system. You install all your libraries and frameworks that your app is going to use, and then you run an app on top of it, the app layer, right? Virtualized deployment, in that case, what you do is you have, for example, if you have different requirements, different operating systems. For example, if your application should run across two different operating systems, so maybe you can have a hypervisor, you can have virtual machines inside of a single hardware, and then you can run your application on top of it. But what Docker does is it tries to make containers out of applications. What it does is it just on top of the operating system layer, it tries to replicate isolation. It takes your operating system, say for example Ubuntu, and it tries to make your containers feel like they are deployed on a single machine, something like that. Right? So you can go ahead and learn about what containerization is exactly and how it works. I won't go into much details at this point, but yeah, that is the idea. So Docker helps you to create applications in different containers which are isolated to each other. You can still make them talk to each other through different methods, but that's the basic premise. And what Kubernetes does is it takes all of these different containers and it tries to orchestrate those things. So maybe you want, say, a certain set of containers to be run in a certain region, right? Or you want some other set of containers to be run at some other computer. So how do you orchestrate all of these things? Like, how do you manage if some of the containers go down, you have to replace them, or other different things as well. So Kubernetes is an open source organization, the CNCF itself, which has a lot of different tools to understand deployment and orchestration. So this is how usually these two tools are used for achieving the cloud native application architecture that we saw in the last slide. So there's another example from Bytemark which I took. So example, you take a monolithic application like a recruitment website. You'll have different tasks in that. For example, you have job applicants, you have job vacancies, and other different roles of people, right? So what you do is you take that entire monolith application and transition to microservices. You split those jobs up into different distinctive elements, and then you create Docker containers on top of them. Like you take each of the, as I mentioned before, you take each of the different microservices with their unique functions, and you try to build containers on top of them using Docker. Now Docker, you know how you build containers. You use some Docker file and other different concepts. I won't be talking about the containerization at this step, but I do have an entire course built on Docker and Kubernetes, which I'll be going to link later on in the chats maybe, where you can see how you understand how all of these things are built, what Docker files are, how do containers interact with each other, and all of the different other stuff. So the basic idea is you take your application, split in different microservices, build containers, and then use some software like Kubernetes to orchestrate those across different nodes or different hardware that you have in your cluster. So this is the idea. Yeah. So why do we do such things? Like, why do we try to separate it into different microservices? So already covered a point that it makes your application more scalable. Can try to individually scale up or down each of different microservices instead of scaling the entire application. The second Could be that you want agility, you want to be you're able to process a lot of different requests coming in at the same time. So it also relates somewhat to scalability. For example, if your traffic spikes up, and if you want to handle a lot of different things, you can just spin up more containers identical to each other, and then they can handle all the requests as well. So this is how it usually helps. And moreover, it makes your application portable, as I mentioned. So if you have a container, you can use any orchestration platform to deploy it on any cluster. For example, if you have a private cloud, if you have your on-premises like system, or if you want a public cloud, so you can just take a code and just run it everywhere. You don't have to make a lot of modifications to your infrastructure code as well. And we can take example of Netflix, Uber, and WeChat here. So these all have a lot of services in production. So sometimes WeChat has 3,000 services in production. Like WeChat, as we know, it handles a lot of different things like payments, food restaurants, and it has a lot of different services built inside of it. So you can imagine WeChat having to build a lot of different microservices which have different roles altogether. Like they're not related to each other, but might want to talk to each other still, right? So all of these different services, you can imagine those being built in different set of containers and being deployed in different regions. For example, if some part of the country has more demand for the ride sharing part of WeChat, so maybe WeChat will make more containers available in that particular region. So all of these things are managed using cloud native approach. So if you didn't have this approach, then WeChat would have a hard time scaling individual components in different regions. So it makes your application really fast and being very susceptible to very receptive to customer feedback. For example, how your customers react, you can make your product react in the same way. So this is how cloud native helps in that sense. Yeah, so now we'll go over to CNCF, like what CNCF is. So Quantum Computing Foundation, it is a consortium of a large number of corporations. We'll be looking at a few of those, and we'll also see a roadmap about it. So what CNCF tries to do is it tries to make cloud native, tries to promote cloud native technologies among different organizations. So it funds different organizations. For example, if you have any project that you feel that would help the cloud native world, you can try to apply to CNCF and see if you can graduate as a project there. So graduating as CNCF will also give you a lot of benefits, like you can feature on their conferences, you can feature on their pages, you get funding as well. The CNCF tries to promote the use of their technologies, open source technologies, so that everybody can use them for their own solutions. And it includes some prominent projects like Kubernetes, Prometheus, and gRPC. You may have heard of these names before. So all of these come inside the umbrella of CNCF. So if you look at this landscape of CNCF, you'll see there are a huge number of different organizations inside of it. I know it's overwhelming at first. And if you look at this corner, this is the CodeDNS part where I interned at last summer. So just a very small part of a large ecosystem of different organizations. So we have something for every part of the journey. For example, if you want container runtimes, you have Containerd and Cryo here. Then you have Helm for package management and other things. You have gRPC for the messaging part. And just if you look at all of these, you can visit the landscape at CNCF's website and try to make sense of all of it. But instead, we'll just go over a trial. Just give me a second. Yeah, a trial map. So is this trial map visible?
Yeah, it is.
Yeah. So in order to better understand the entire landscape that we saw, we can just go over step by step, and we'll see how each of the different what do you call it? Yeah. So just give me a second. So we can understand how each of the different processes are handled by different services. Okay, I think I zoomed in a bit more. I should have. Just give me a second. Yeah. So we already talked about containerization, and you have some idea about how containerization is done. It is taking application and building Docker containers on top of it. So this is the first step. In the second step, you try to set up continuous integration, continuous delivery, like we talked about GitOps and the entire cycle there. So you can set up some workflows in order which are triggered when you change some code inside of application. So you can use projects like Argo. Argo is still an incubating project inside of CNCF, and what Argo does is it has a workflow where each step is a container. So if you're running some workflow there, so it makes your workflow also scalable and portable as well. So just take different steps, and all of these different steps are in fact containers of their own. So they all have some fixed job, and they They can be run as many times as you want and across any platform that you have, right? So this is how you can build workflows using the Argo project. Then you go over to orchestration. So once your containers are ready and once your pipelines are set up, you need to have some software which you can use to actually take all those containers and deploy it on your hardware. So all of that logic is rests in the Kubernetes, and Helm is also a part of CNCF. It allows you to manage all your different packages. And Kubernetes is the software which is not software, it's a very sets of tools to help you organize the logic into what, how do you call it? You can think of it in such a way that it has some ways in which you can optimally distribute all of your different pods across the cluster that you have. So it allows you to do that. After you have deployed the application, you want to observe and find out if things are working as they should, or if you want to run some machine learning model on all of your application to find out if there are different errors which you can't detect. You need data, right? You need to understand the different metrics coming from your application. So you can use Prometheus in that case. So Prometheus, if you build Prometheus into your application, you'll find metrics, you get metrics from your application in real time, and you can then view those metrics in different dashboards like Grafana and other dashboards. So you can get an idea of how your application is performing and if there are any other changes that you need to make in your application. After that, you can also think about service proxy discovery and meshes. So for example, if your application has grown too huge, like there are a lot of different services, so then finding and communicating to each service, it becomes a lot of trouble. Like you'll have to write a lot of logic to get to different services. So in that case, you also use a service mesh. So Linkerd is one of the service meshes that you can use for this case. Service meshes are just help you to actually, it performs a lot of different services, but I'll just maybe point out a very short few. First of all, it helps you to get to the service you want to get. For example, imagine if there are, like in case of WeChat, there are 3,000 different microservices. So if you want to talk to some particular service and if you want to talk reliably, like you want to retry if your first call fails, and all these things are handled very efficiently by using a service mesh in that case. CoDNS is used for it provides the DNS service to your Kubernetes cluster. For example, if you want to talk to some other microservice, you don't want to use the entire IP addresses every time. So you can also just refer to the DNS name, and CodeDNS will resolve that name to the IP address of the different IP address of the pod and where it is on which node it is deployed on. This is how CodeDNS helps you. So service discovery and mesh is also an important part of the journey. Then comes the network policy and security. So you also have just like CNI, an open policy agent. So CNI is the container networking interface. I also have a video on the same on my YouTube channel. So CNI is responsible for, this is actually a set of different tasks and different roles. For example, when you start building a container, all the different network configurations that go on behind the scenes are defined by CNI. And CNI is just a common interface that whenever different companies approach this problem, they have plugins they can choose from. They don't have to write the entire code themselves because in most of the cases, all the logic remains the same. So when you create a container, you'll have to create a different namespace, a network namespace for that container. You need to also then plug it into the rest of the network so that you can talk to the external world or other services. So all of these steps are really same for different organizations. So CNI tries to standardize all of those principles into a single set. This is what CNI is basically. Apart from that, you have distributed storage and databases. So etcd, you may have heard of this name before. So it is used by Kubernetes itself. It's a key value storage. You can maybe think of it in that way. And it has a big role to play success of Kubernetes. Streaming and messaging, as already mentioned, gRPC is a RPC framework made by Google. So it is remote procedure call. So you can think of it in this way that it's an alternative to REST, where API used to REST APIs. So what it does is it has a gRPC server and a client. So you build actually the entire interface inside of your application. And then what you try to do is you just call the function. You don't, for example, you may be used to making REST calls, for example, get call and post calls, and all the different types of calls to get, for example, if I want to get a list of photos, I'll take an API, REST API, and I'll make a get call to the REST API. But in gRPC, what I do is I already know that I'll just get an interface, different functions like get order or
Hey Jayesh, we lost audio for a few seconds there.
Can you hear me now?
Yes, we can now.
Okay, maybe there's a problem with my headphone. I'm sorry. Yeah, so I was just talking about gRPC and how it works mostly. So yeah, maybe you can see that it's not really. Hello.
Yes, you're audible, Jayesh.
I'm on. Yeah, sure. Thanks. Yeah. So yeah, just talking about the different parts in the journey there. So streaming messaging also important part, and CNC a lot of different projects in that case. Then you have container registry. So all of your containers, for example, that you build should be stored somewhere where they can be accessed by your cluster. Like you should have a common registry of all of your containers so that your clusters, wherever it is running and wherever it's required, they can pull those images and build containers on top of those. This is a registry, and again, software distribution. So these are all of the different steps which CNC has thought of and built a trial map on, and all of these have different organizations under CNC which you can use to design a solution for your application in that case. So we'll jump back to our PowerPoint. Yeah, so why should we choose CNCF? CNCF organizations. So you can take advantage of all of the different projects which are available, as you already talked about the different one, and you can use those directly into your product, and you can simplify your development process in that case. Usually, if you think of in the previous times, if you wanted to implement some new feature, you would have to hire a lot of people to work on it and build the functionality there and then. So, but now you can just figure out what part or what step of the journey you want to add a different what you call functionality to, and you can usually find a project in the CNCF which you can leverage in order to achieve the same functionality with some modifications. So this is how CNCF allows you to save time on like basic cloud native architecture, and then instead focus on your business logic and also maybe integrating new technologies like machine learning inside of your applications. This is how CNCF allows you to build cloud native architectures better. Yeah. Now we look at some of the common prominent projects here. So Container D is one of the prominent projects. We already saw it in the container runtime section. So Container D is a pretty extensive used, because you may have also heard of Docker. We already mentioned Docker a lot of times, and we can also know that Kubernetes used to use Docker before, but now it's just shifted to other containers runtimes. So Container D is one of the container runtimes that allows you to run containers on top of your infrastructure. And as you can see, there are different details listed here. You can check out the repository there. It's a very happening repository. You also find out of issues if you want to work on it. And then we have the Kubernetes. You may have also very probably heard of Kubernetes. We already talked about it extensively throughout the entire presentation. So it's also a part of CNCF, and these are the different stats for it. The languages which it is built on is Go 90%. So you can go ahead and check the repository as well as the different other links which I have here, the website and other things. Then you have Core DNS. As I mentioned, it provides DNS services to the cluster. So it's also one of the very prominent projects in the CNCF. And apart from those, you also looked at all of these things in the trial map there. And this plus a lot of other organizations as you look down the landscape. So these are some of the projects which CNCF hosts. How can you start contributing to CNCF? You can just, all of the different organizations have standard guidelines which are developed by CNCF. For example, I'm just sharing a screenshot of the GitHub link to the Core DNS contributing guide. So it has all of the different ways in which you can start contributing. You can identify bugs, and maybe you can file a pull request in such cases. So all of those have very strict set of guidelines that you can follow, and usually this will help you get started with development. And the next step, as an incentive, you also have the LFX mentorship program. Now, what this program is, it usually is a way for all the projects inside CNCF to get to get mentees to work on different projects that they have. Like I'll just go over to the website now, to the mentorship page. You may have heard of GSOC before. It's somewhat similar, but it's only for persons inside Linux Foundation. So if I scroll down, I'll see the mentorship section. If I click on view all, I'll see all the different organizations which are currently only one of them is accepting applications right now. We just had a recent batch of CNCF currently. So these are all the mentorships which you have available. Most of them have the applications closed, but it runs maybe 3 times a year. So you can always find out when the next batch starts, and you can start applying to all these different companies. So I'll just click on one of them, and then we can see how you go about it. For example, just let me check if I have. Yeah, so maybe GraphQL. So you may also heard of GraphQL before. So there are different projects in this foundation. I just go over to the OpenTelemetry one for now. So you can just have an idea of how different things are. Yeah, so it looks somewhat like this. You have a list of mentors here. Applications are currently closed, but when they're open, you can apply directly from this website. And then you have to submit cover letters, you have to submit your resume and other stuff, another list of tasks that the mentors wanted to perform. You can look at the repository here if you want to understand what this particular mentorship will be about and what you're going to work on. The list of mentors are here. You can talk to them, understand what the problem is, join the community Slack, and try to understand how you can start contributing to all of this. And these are graduated mentees, which you'll find. So maybe you can reach out to them, talk to them, and understand what the experiences were with OpenTelemetry and how did they fare in that particular mentorship program. This is one of the ways. If you open the GitHub repository, you'll find out all the different organizations and the inside of OpenTelemetry, and then you can click on those repositories, find out good issues to work on, engage with the community, and this is how you actually start building it. For example, it also has a contributing MD file. So every project itself has this file which you can visit to understand all the different rules and all the guidelines that they have in place for people who are willing to contribute. This is a step you just should take if you want to also have an incentive to start developing or start helping the projects in the CNCF. So I'll just encourage you to go over to the mentorships page and find out all the mentorships you can maybe work on. You'll find a lot of these things are really, they require you very specific skills. So if you want to develop those skills, if you want a place to start, if you have, because CNCF has a lot of different skill sets. So if you are not sure what skills you should start working on, maybe looking at the different projects and looking at the skills section will help you get an idea on what skills to pursue right now and how you can go. You also have a project to work on it side by side, right? This is the entire idea of behind the LFX mentorship, and you also get paid really well for being a mentee in this case. So this is all about contributing. Now maybe Sangram will talk about the different skills that you have, that you need to have, and the statistics which will encourage you to start contributing to CNCF. Over to you, Sangram.
Thank you very much, Jayesh. That was a lot of details in that time frame, right? So if you are overwhelmed with the fact that there is a lot that is going on with cloud native, and you would like some more information on what should you choose, what skill sets probably you can start off with, and also if you're still not convinced, some numbers ideally convince people to kind of look into these things a little more seriously. That usually happens in the IT industry. So we'll go ahead and take a look at some cloud native statistics. These are over 2019 and 2020. And we will also look at some of the skill set wise, some of the tools that are very popular, and maybe you can pick one or a few of these tools to begin with, to begin your cloud native journey. So I'll take roughly around 30 minutes for this, but trust me, the slides are exciting. And if you're someone who is in the college, if you are just starting your career, or if you are an experienced professional, you will find inputs on how to get started with cloud native. All right, so here are some statistics to get you pumped up, and along with the statistics, I will also point out as to what is that particular technology or tool that is popular within that within that stat, right? So if you look at the container adoption, we have actually seen 300% increase from 2016, and from 2019, where it was 84%, we are currently at 92% container usage in production. So you can say that maybe next year, this year when that survey is out, this is the 2020 survey, maybe we have 100% of the companies running some sort of workload in production using containers. And we already have 95% of the survey respondents use them in POCs and dev and test environments already, right? So container adoption is something that we have seen spiral over the years. And obviously we are nearing the 100%, but this just goes on to show that containers are something that you should definitely probably learn when you talk about cloud native, starting your cloud native journey, right? Let's put it that way. Similarly, when you say containers, the obvious technology that people refer to next is Kubernetes, right? In fact, if you talk about cloud native, maybe you will hear Kubernetes first. With Kubernetes, which is a container orchestration software, helps you orchestrate containers at large, thousands and millions of containers. We have seen a huge growth here as well. And we see this year on year growth on the adoption of Kubernetes. From 2018, when it was 58% to 78% last year, we have Kubernetes used in production at 83% in 2020. Right, so we are again seeing Kubernetes adopted in production scenarios by enterprises, not just cloud native companies, but also typical enterprises that have been known to be a bit reluctant in adopting new technologies. The common cluster size that we see is typically 2 to 5, and we've had increase in terms of customers using a higher cluster size as well. So we see a lot of customers going more than 11 number of nodes in a given cluster. So that's another technology for you to learn. Kubernetes is obviously going to, kind of be a highlight in your profile, highlight in your resume. All the cloud native roles that are out there, they definitely look for Kubernetes experience or knowledge. Now that we have spoken about a platform where you can run cloud native applications, when you want to operationalize these applications, right? Right from testing them for code coverage, testing them for bugs, vulnerabilities, to building the binaries, to deploying it to some targets, maybe some virtual machines or more cloud native services that cloud vendors have out there. You will obviously end up using CI/CD tools, right? And we see that CI/CD is already used in production, and we have 82% of the survey takers say that they're already using CI/CD pipelines in production. And obviously Jenkins, GitLab, and GitHub Actions are the top 3 most used CI/CD tools. Jenkins, you can see, it's at 53%. It's obviously the leader. And again, look at any cloud native role, maybe a bit more on the DevOps side or site reliability engineering side. You will see that Jenkins is something that they obviously kind of look at. Similarly, another term that is used often with cloud native is serverless. It's where you're computing loads using a service layer or function, and you are able to dynamically deploy cloud environments and scale them on demand, and in many cases only pay when the code runs, right? It's very, very flexible. AWS Lambda takes the top spot in terms of adoption. So that's there again a clue for you in terms of what kind of serverless technologies should you get started with in case you want to decide on something. There are some numbers there that can help you, right? But pick any one of the 3 cloud providers, AWS, Google, or Azure. You are in a good spot in terms of serverless skill sets. Obviously, we have around 30% of the companies that use serverless already in production. We again see that these numbers will obviously grow. But having talked about Kubernetes, I can say that Kubernetes kind of shadows a bit compared to adoption of other technologies. Functions can run in Kubernetes, function as a service. So we're seeing adoption of serverless into Kubernetes a lot nowadays, right? So that integration is helping, obviously, companies that are looking at serverless as their code running platform. Joyce spoke about service mesh, right? It's a dedicated infrastructure layer for making communications between services fast, secure, and reliable. It's like, think of the postman service or the postal service as an analogy to this, right? You just give a PIN code and you are able to kind of get the parcel at your place. It's up to the postman to figure out the building and all of the details just by looking at a PIN code to begin with, and then gradually make sure that the parcel goes to the right door. Again, we see that service mesh is already in production. The reason we keep referring to production, especially in my slides, is because I want to let everyone attending my sessions know that when we are asking you to look at these skill sets and tools, we also want to let you know that these are actually used by companies. A lot of the times, many people look at skills and technologies as to what is currently being used by companies, because otherwise it's more of a learning, which I don't think it's a bad idea. But given that the way the industry is, a lot of the IT professionals look at, okay, will this help me in the next 6 months or 1 year? Is this something that companies are actually using? And I went through this with OpenStack. I'll be honest with you. When we were just getting started with OpenStack, a very common question was, will companies use OpenStack in the next future? So for some time, OpenStack was really popular, really hot, especially in India. But again, it's used by enterprises. I'm not saying it's not popular, but not as much as take OpenShift or Kubernetes, right? So obviously, IT professionals are keen on knowing if companies are actually using these approaches or tools or skill sets in production, right? So yes, they are, and we will obviously see a growth in these, and it will be an investment that will pay off, in the longer run, is what I mean. Now, from a service mesh perspective, Istio is the most popular one used in production, but then Linkerd is catching up in terms of production as well. And Console is also something that is often, referred to in blogs and used, and companies, look at these skill sets. Similarly, service proxy is another component to cloud native. It manages interactions between microservices to ensure you get the right performance and ease out the operation of cloud native architectures, right? Again, production usage is already there, and Nginx takes the top spot when it comes to service proxy tools. You have Envoy and HA proxy next in line. So obviously, if you know Nginx and you understand how service proxy works, for a complex organization that is also more cloud native and uses a lot of microservices, you have a skill set that works for them. So overall, if you look at the cloud native benefits, right, adding up to what Jayesh said and what we saw over the previous slides, you will see that one of the reasons companies look at cloud native is the scalability part of it, right? And then the next is the shorter deployment time. You are able to hit the market faster. In today's competitive world, you cannot wait for even a day before you release a feature, right? Someone released a capability to make payment through PhonePe and Google Pay. You also have to be quick enough in doing that. Otherwise, you lose customers. So in today's faster time to market requirement scenarios, shorter deployment time, which does not compromise on security, which does not compromise on your tests, is what is required. You have to be agile, and that also means you should be able to deploy faster, get value-added features, or get features, get anything to the customer faster. Today's customers don't wait, right? So shorter deployment time obviously is the second most selected benefit when it comes to customers using cloud native. Obviously, improved availability, portability, developer productivity. You can see that all of them are almost on the same lines, right? So all of these are benefits that enterprises, cloud native companies, or anyone just getting started is looking at, right? Not just cloud native companies, but also enterprises are beginning to understand the benefits of cloud native, and they're obviously working on using them. Yes, if you come from an enterprise background, many of the enterprises might have to end up re-engineering or re-architecting their applications to kind of get these benefits. We'll leave that for some other discussion sometime. It's not that every application in its existing state, can just be converted into a cloud native. It involves quite a bit of work, but then there are benefits to it as well. Right. So now that you understand that these numbers, actually make sense and they're used in production, and you heard about some of these, top tools or technologies that are popular in that cloud native component. Let's take a look at, how do you approach it, right? Now, one of the questions I get often is, cloud native has a lot of tools and technologies. You look at the cloud native map, it's so overwhelming. How do I start, right? And I say that you can easily break down cloud native into various, areas, right? So there is the architecture part of it, where you might be an architect, and more or less what you're looking at is designing the architecture, right? So for you, it's all about understanding what microservices are. So that's probably where you can start. Right. If you are an application developer, right, you can look at application development as the area, as the cloud native area to begin with. So you can look at what programming languages are popular. Say Go, right? Or let's say Ruby, right? C++ maybe. Pick out the top ones, and depending on your area of interest, you can probably go quickly to the mentorship page and see those projects and see what those projects are written in, right? And pick out maybe an application programming language that is used in a lot of projects. And then for developers, it also makes sense that you learn a bit about cloud native development practices. And one of them is using cloud native IDE tools, right? So this is where using IDEs that are browser based, right? Eclipse Che is one of the examples of a browser based IDE. They're all cloud based. Gitpod is also something that you can look at, but then it's more on the operation side. So we'll get there, in terms of operations and automation. But we do have a lot of cloud-based IDEs coming in. So instead of having an environment that you build, which may not be consistent when it comes to moving those applications to production, maybe there is security concerns as well. Cloud native IDEs provide you that consistent environment that works everywhere, right? Plus, you don't have to worry about building that environment. You can easily get any of the tools that you require, or SDKs or libraries or runtimes required, installed very fast. If you use Visual Studio Code, for example, online, or Visual Studio Online, or Eclipse Che, you understand what I mean by that, right? So if you're a developer, maybe this is your area to begin with, right? Someone who's more of an operations, maybe a system admin guy, someone who creates virtual machine images, can look at packaging, right? This is where you learn a bit about Docker and how to use Docker to create Docker images, which will eventually be used in the platforms. So if you're someone who is a sysadmin, who is a Wintel person, you can probably look at the platform part of it, learn what Kubernetes is, right? Learn what Docker is. Right. So these are certain things that you can look at. NOC people, network operations, or people who do operational work a lot, can look at automation. So for you, Ansible makes sense. For you, Terraform makes sense. These are also cloud native tools. So maybe you can start with this, right? If you are someone who is more like born in the matrix, I would say, right? So for you, you are probably looking at roles like DevOps, SRE, right? So for you, CI/CD matters. So you look at GitOps, Git, Gitpod. These are tools that you can begin with. These are technologies that you can start learning. Similarly, again, if you are a NOC guy who is part of operations, and maybe monitoring is something that is what you do currently, you can look at monitoring tools that are cloud native. Prometheus, right? There are many more tools around monitoring as well. Or if you are someone who is an overall again, cloud would fall under the platform management or virtual machine creation, bare metal server setup, that kind of a area. I would say learn AWS or learn Azure or learn Google Cloud, right? So all of these also eventually lead to cloud native adoption. So you would run cloud native applications on mostly public cloud platforms. In fact, CNCF survey says that public cloud is still the preferred platform to run cloud native applications. So try and pick where you are in these areas of cloud native in terms of skill set, and then pick a tool that works for you, right? Obviously, when you say I am cloud native, I have cloud native skills, we expect more than one skill set. Unfortunately, that's how it goes in today's in today's IT landscape, or in today's IT ecosystem. You need to know more than one tools. But to get started, you can pick your comfort zone first, because then it won't be too overwhelming to understand how it works, because you understand that it does monitoring. It's just that instead of using maybe Nagios, which works slightly differently, you are using Prometheus. Right. And then once you slowly start learning Prometheus, you'll realize that, okay, Prometheus needs to run as a container. So yeah, I mean, it runs in a Kubernetes cluster. So yes, you kind of then have the other thing to learn a bit about. So you learn about Prometheus in terms of the theory on how it works, the architecture. And then before you go and install Prometheus, obviously it means you need to know a bit of Kubernetes. So that's your step number 2, is to learn what Kubernetes is and how it works, right? So you can pick one of these based on where you are, and then use that as your starting point to learn some of these tools or technologies. And I will obviously recommend that you don't have to know everything, but I would definitely recommend that it'll be great if you know multiple tools, because that's what today's cloud native roles expect. So for example, if you are a DevOps person, you will kind of need to know Jenkins or GitOps, something like that. Obviously, you need to know a platform, which is Kubernetes, or maybe something else, Docker Swarm or OpenShift. These are some platforms. Maybe some security tools here and there, but then a lot of these can be added as part of the pipeline. And then somewhere where you want to deploy it, right? So maybe a bit of Azure, Google Cloud, or AWS. So these are 3 or 4 basic technologies that you can obviously begin with. It's not a lot. Unfortunately, if you feel it's a lot, you still have to get to it if you want to stay relevant. And you can see that enterprises are definitely adopting cloud native. So maybe a few years down the line, core enterprises like banking, finance would be looking at cloud native mainstream. We do have telecom companies already adopting cloud native approaches to their calls. So talk about network function virtualization or network virtualization, right? NFV, and then all of these run in container approaches. They leverage the power of Kubernetes. They run on edge, right? So edge computing also comes into play here. So we are already seeing this with especially telecom companies. Jio, for example, Reliance Jio uses, by the way, they use OpenStack, but then they leverage a lot of these container technologies as well in the background. Not entirely, but yes, they are good in terms of adopting cloud native solutions. If you're a developer, let me tell you that you're not alone. We already have 4.7 million cloud native developers. So you'll find a lot of community support if you are getting started. We already have almost close to 2 million developers using Kubernetes. This is a 2019 survey. So obviously the numbers are higher now. And as usual, you will find Kubernetes being referred to right? And you see that Kubernetes users are more likely to influence buying decisions. AWS Lambda is what is used in serverless. So you already get an idea on where you can start in terms of learning cloud native technologies, right? Kubernetes, if you're a developer, Jenkins, GitOps, if you're a sysadmin or an infrastructure guy, look at Kubernetes, learn a bit of serverless, AWS Lambda. So you know where to start easily because you've seen what is popular at the moment, right? So we see a constant growth in terms of cloud native development practices as well as cloud native developers. And some of these skill sets, skills, programming languages, tools are in great demand. Our aim as the community is to have more of these webinars or meetups and bring these tools and technologies to you over the course of time. So here is a final slide to end this. And it's great that I'm on time, actually. What do we see in terms of cloud native trends, right? So yeah, we see Kubernetes is popular, great. Jenkins is popular, sure. Nginx is popular, sure. But what's next? What if you are, someone who always wants to know what's next, and you are always looking at the cutting edge side of technology? So we see that cloud native development, especially in terms of the IDEs, will grow. Companies and developers will use more browser-based consistent environments to collaborate rather than doing local development. So it's like you can develop from anywhere. You open the browser and it works. Obviously, there is the network dependency part of it, but let's keep that aside. We also see that multi-cloud will be, sought after. We already have companies that are using multiple clouds. Hybrid cloud is also going to remain in demand, and especially technologies like Kubernetes and Google Anthos have actually made hybrid cloud very easy because you've got a consistent environment, whether it is public cloud or private cloud. You're able to run Kubernetes on-prem, you're able to run Anthos on-prem, right? So one of the things about cloud native is that we want to give you tools and technologies that are agnostic. By agnostic, what we mean is that it should work anywhere. So Kubernetes and similar technologies actually do that for you. You want to just move everything away from AWS and move to Azure, or from Azure move over to Google Cloud. You should be able to do it very easily because the construct for that stack is agnostic. Same container images, same YAML files. You run them anywhere, it works. As long as the container images can be downloaded. Do they need proprietary format? No. Whereas if you had a virtual machine that you're moving from AWS to Azure, you would probably have to convert the format from AMI to VHD. So we don't have that kind of a lock-in. We also expect containers to be used on edge a lot. Kubernetes, especially on edge, we're seeing a lot of trend around it. Enterprises are increasing Kubernetes adoption, especially in the industrial Internet of Things use cases, right? Companies like Starbucks leverage a lot of these. There are many of these, food chains that are running containers on every food chain branch that they have. Let's say they have 2,000 branch, or hundreds of branches. They run an edge computing platform locally on that particular store, and any recommendations or calculations or any device failures, they are all quickly responded to because of the low latency, because any calculations, any computing, any storage that is required is available locally, right? Plus, because of edge computing, many companies are also able to achieve data compliance because you don't take the data out of a region for processing and things like that, right? So that's another great benefit to edge computing. We will see a lot of focus on cloud native security or DevSecOps because of the way we are now doing everything on cloud native. And there are so many movable parts to today's applications. They are decoupled, distributed, they are microservices based. You have so many components. you obviously have a lot of threat vectors, right? Your surface area is bigger. So there are various ways to compromise that an attacker or a hacker can find out. So you will see greater focus on security. I've done a couple of cloud container security 101s with the open source summit. You can find them on YouTube if you want to take a look. I talk especially on container security, not on Kubernetes security or other aspects. There are obviously the 4 C's of cloud native approach, but just focus on container security. So maybe that's of use to you if you're someone who comes from the security background. We will see the use of service mesh, considering microservices are increasing in number and you want to be able to scale them well and at the same time be able to interact with the microservices and make sure they work without interruption. We see that service mesh will be talked about a lot, and obviously automation. Companies are looking at using managed services, and this is where we especially see companies even looking at using managed Kubernetes, so AKS or Azure Kubernetes Service or Google Kubernetes Engine, or the one from AWS. I think it's called EKS. They are all very popular now because no one wants to sit down and build a Kubernetes cluster and manage it themselves. Similarly, in terms of serverless or in terms of talk about even development IDs, right? Everybody's looking at managed services. So we see an increased use of managed services, especially in terms of automation, because you don't manage them, someone else does it for you. It becomes very easy for you to kind of focus more on the application part of it. So you automate the administration or the environment upkeep, patching, security, automation, and the intention is just to focus on the development of the applications. So on that note, if you are someone who comes from a background like mine, and I say this often, it's time that you learn something around cloud native. It can be as simple as a, as Ansible or Terraform, which can be an automation tool, infrastructure automation or configuration automation tool. Or if you're feeling adventurous, and I know a lot of people from my experience actually learning coding at this age. So nothing is impossible if you want to stay relevant. Obviously, cloud native is one of that you can pick up, and feel free to choose from one of those tools and technologies that we spoke about, and begin your cloud native journey. You obviously have the community to help you, right? So good luck with that, right? With that, I appreciate you taking time for this meetup. I will open up the mics. If you have any questions, we'll be kind of happy to address them. Just give me a minute here. Right, so the mics are on. If you have any questions, please feel free. There was something about making these presentations available. Yes, obviously we will put them in GitHub so you can refer to them. We'll also try and put the recording up. Let me see, how easy or difficult it is, but I'll try and do that as well.
Am I audible?
Yes, Ahmed, you are now actually.
Okay. Actually, I have a question. To be honest, I'm totally new, kind of a beginner in cloud computing, but I'm interested. So I have started learning about cloud, but I have still one doubt that what should I do? Should I learn about the tools and platforms, or I started working on some kind of small project and then learn about tools, or go for some examinations? What should I do first?
I would definitely recommend you to learn first before going for exams, right? So you can take this approach if you are starting with cloud. I'm not sure which cloud that is, but many clouds have a fundamental level that you can start with. AWS has practitioner, Azure has AZ900. I'm not sure about Google. I don't think they have something fundamental, but you'll find similar. So that can be. So along with that, right? Again, if you are able to juggle multiple things together, along with that, you can pick one of these cloud native tools. You obviously have picked one of the platforms, more like a public cloud platform where you would run your cloud native applications. At the same time, you can learn some of these. Maybe you can start looking at containers, right? I'm not sure if you're a developer or if you are someone who comes from a sysadmin background. Maybe you are a tester, you're someone from security. Depending on where you come from, you can obviously, along with that, learn a bit of maybe Docker and then move over to Kubernetes or directly get into Kubernetes as well, considering that the dependency on Docker is kind of going off. If you're a developer, you can get started with learning Jenkins and how to do how to create CI/CD pipelines. Maybe that along with the public cloud platform can be something that you can take up together. I hope that kind of gives you an idea on how to take it forward.
Thank you.
Which cloud platform have you picked, or which cloud are you learning?
Actually, I have started in AWS, and I have kind of completed the basics. I know of about few tools, and I have started experimenting with them. Like a few days ago, I was trying to host a web page. That's
absolutely it. So that's a great starting point, right? So the next thing that you do is see how you can automate the process of making a few code changes, and that code automatically get pushed into the EC2 instance. Let's assume that you are using. So that kind of will put you into a path where you will learn, okay, for this I need to learn Git, and then obviously use a CI/CD tool. So maybe learn Jenkins or GitOps, right? And then there you are. You have a couple of tools that you've learned that are on the lines of cloud native.
Thank you. That was really helpful.
Can you hear me? Hi, this is Dipankar.
Yes, Dipankar.
Yeah. So I wanted to ask something like, let's say something you are picking up today. So is this something already booming in the market, or we should better choose something is like, down the line 5 years maybe, because these things are getting outdated, or like you can say out of market pretty soon, things what you learn now. So we should look into bigger picture, or like we should focus on what we are doing currently. So
you can actually get a bit of both. That's a very interesting question, though. You can actually pick a bit of both. So if you want to kind of learn a few technologies that will remain in the future, then we do have some of those technologies even in the cloud native part of it. So I know enterprises that will probably not call themselves cloud native in the typical sense, but they still use something like Kubernetes, right? Or they adopt DevOps. So CI/CD
yes,
tools, Kubernetes, they will be there 5-10 years down the line. So maybe that's your sweet spot where you get the best of both, worlds. Yes, it so happens that when you talk about an open source project, right, it happens that some of the projects actually do not get the kind of attention, to kind of take it to the level of being used in enterprises. And many of us do come from those typical enterprise companies. I agree on that. So yeah, for people like us, I think it makes sense that you look at tools and technologies that have shown to be adopted by enterprises as well. And the examples that I can take is obviously Kubernetes and general DevOps practices, right?
Yes, right.
Again,
Actually,
the tools might change, but the DevOps process will remain the
yes,
same.
exactly. So that is what I'm saying. This is one of the drawbacks in enterprises, no, right? If it is not
Yeah,
falling in sync with them, then basically whatever you are gaining all these stuffs, I mean, learning all those things on your own, they're not going to help you much unless it's like it's going to really helpful for a cause. I
right.
mean, in the interest of the company or organization or enterprise, be whatever. That's how, just like, yeah. My
Yeah, what
question
we are
was a bit
seeing,
like generalized question, yes.
yeah, what we are seeing is that CNCF foundations and similar foundations are also, working with enterprises so that they are able to adopt these technologies. So yes, something very, very new or latest can obviously not make sense to IT professionals who are working with typical enterprises. But yeah, you'll have to kind of spend some time and pick the ones that you that obviously over your findings and research you think will kind of remain uh, what do you call it, active
Yeah,
over the next few years.
To implement all these things like collectively or whatever we have in the slide. I mean, in your slide deck, we saw in last 30 minutes. Let's say a good programming languages. I mean, a programming languages. I mean to say like more about scripting, automation. So these are all things. Are I just wanted to check is this R or Python or kind of like which one would be most preferable one in the market now, so that it's easier to learn. And I mean, I can't say it's easier, but I'm saying in comparison to like we can use it in most of the platforms, what I mean to say.
Yeah,
Right.
so
This
most of
Terraform
our
kind of things, right?
CNCF tools are agnostic, so you can pick. Again, Terraform and Ansible are not part of CNCF, but just saying that they are agnostic tools and they would work even on-prem or even with virtual machines on-prem and cloud and anywhere else. So you can obviously pick these, and I would say Terraform is easy to begin with. From I mean, in terms of the learning curve, it's easy. It's used widely as well. And we are using these tools even for bare metal and typical data center deployment too. So, I can tell you for sure that they stay relevant no matter where you are.
Yeah, right. Thank you.
Ansible, Terraform, yes.
These are helpful, Sangram. Thank you.
We also see enterprises, right, on that line, right, for everyone. We also see enterprises actually looking at a cloud native approach to building an absolutely new version of their application. So let's assume there is an enterprise that is already having an established application, right? They realize that the business landscape is changing, customers is changing. So many of the companies also parallelly start building a cloud native application. That's also one of the trends that we've seen. Again, not every industry might adopt it, but definitely CRM industries, ERP industries are looking at cloud native approaches for the newer version of their applications. So they'll obviously have the versions that are already there. And one of the biggest examples that I can give you, not on the lines of cloud native, but on this mindset, I think that's the right word, is SAP, right? So over the years, SAP has actually made it very clear that they will no longer build new updates for the older applications. They actually want companies to move to HANA, and that's more on the lines of cloud. It has been re-engineered so that it works well on cloud. In fact, I see that they are working a lot with cloud platforms to make sure that SAP works on cloud, rather than I think they've actually made a deadline of 2025 when they will actually stop supporting the previous versions of HANA and things like that. So yeah, I think that is that another angle of mindset that comes into play, and some enterprises are yet to get there, but hopefully we learn these. And these the thing with technology is that every 5 years or 10 years you have something that comes up which kind of changes the whole landscape. And currently, containers and serverless is what will continue to remain until we see something more game changing, maybe another 5-10 years down the line. Just like virtual machines were, or just like Linux was, that is what containers and Kubernetes is at the moment.
Yeah, in this current scenario, if you see like the day, I mean, Red Hat is killing CentOS. The way Red Hat been from open source, it's going to like IBM. They have acquired it. Like this kind of situations when you have your scope is getting limited in your open source, then yeah, we need to look into this perspective to explore ourselves in the containerizations. That's every organization is now looking for. I mean, if a cost is coming into the picture, yeah, definitely yes. That's how, yeah, it goes, right? I completely agree on the statements you made, Sangram, here. That's correct. Yeah. And one more thing, like my question to Jayesh. Sorry, yeah, Jayesh is there.
Yeah, he's here.
Yeah, just so I just wanted to check one thing is that being a newbie to CNCF, what do you suggest? Like you are mentee there, and you have been here around for almost a few years, looks like. So I mean, what do you suggest? Like how can we take our approach to that as a newbie or kind of things? I mean, though I've been a traditional infrastructure or architecture for almost like 10 15 years and more than that, but yeah, since we are getting exposure to cloud, like native clouds, I mean native cloud technologies, or inside that whatever services we are getting, but moreover getting all this together to a single frame of work or frame of mind, we wanted to learn something, then what should be our steps, like what should we approach, like how should we move further? Just one of the questions I wanted to ask you.
Yeah, sure. Thank you for asking. Usually, the approach that I take on ready to learn different alternative technologies is looking at the trends, first of all. And then I look at all the different mentorship programs that are available currently. So mentorship program not with the only purpose of applying to them, because you can't apply to them again and again, but with the purpose of understanding what the different issues are with all the organizations. For example, if you have, because if you look at just the repository and the issues, you maybe don't have a very clear story which you can understand about the different things that you require help on, right? Because most of those issues are related to each other's, and they are a lot of they are seem connected in such some way. So you have to really go down the line to understand the entire problem that the people are talking about. But if you look at the mentorship pages, there the issues are really presented in a very beginner friendly format where you can understand, okay, this is a problem and these are the things which they need to work on. So this is one of the steps which I take in understanding the organizations and what work there is available for me at this stage. This is one of the parts, and the next step is learning about where the world is going currently. For example, maybe exploring the edge part, as Sangram already talked about. Like a lot of organizations are now switching to edge for data compliance as well as for low latency. So figuring out how the edge works, and like mostly it's a way, it's about the inquisitive character. Like you have to investigate yourself and understand how different things work. Like I was always intrigued by the edge deployments and how those work. Apart from that, I also have an interest in how the services discover each other's. Like that's why I took interest in core DNS in the first place. So always interest, for example, if you have multiple services, microservice deployed in a cluster, how do you effectively communicate? How do you find out their locations and all this stuff? How do you prepare health check? How do you understand if your services are up or not? So mostly driven by two things. First is interest in understanding how the systems work. And the second thing is going out to the mentorship page and finding out what are the hot issues that organizations are currently working on, talking to the mentors, maybe it's over mail and understanding what their current issues and where they want us to work on. This is some of the two parts. I hope that clears your question.
Yeah, excellent. Thank you.
Yeah, no problem.
All right. I guess if there are no questions, I'd like to thank all of you again for taking time out on a Saturday for this, and hopefully I'll see all of you in the next set of meetups or webinars.
Yeah. Thank you so much, Prash. Thank you so much, Sangram and Jayesh. It was so helpful.
Yeah. Thank you for attending.
Thanks.